This is a modular test equipment rack I designed. I already did a full video on the CB microphone tester. And this video is an introduction to the concept, a brief look at all the modules, and I will do a video on each of the modules later on. And all the designs, or most of the designs, will be published on my GitHub page, including the circuit boards, schematics, software, drawings for the bezels, basically everything. So why do I need all this equipment? Well, back in the late 70s, I didn't have much money. And the local electronics store, they sold some components and a few multimeters, and that was about it. So if you want to have some test equipment, you have to build it yourself. So I did, like this one, for example. This is something I built back then from Electro magazine. Still works somehow. I need to revise it someday. Audio generator. Very nice, was very useful. So that was the only way to get nice test equipment, building it yourself. So I built a lot. I made some designs myself. I published some in a local electronics magazine. Moving forward to today, meanwhile I have a lot of professional test equipment, vintage from the 70s, 80s, 90s mainly. I'm now retired and I still like to build my own equipment. So also I don't like things with batteries. I have a lot of small testers with batteries. When you need them, when they're rechargeable, they're empty, and otherwise they start leaking. So I don't like things with batteries. So a few years ago I made an universal tester, which was huge and had a lot of functionality in one box, but the pain to work on, 2 big circuit boards, 9,000 lines of code, not very practical. So I was looking for a design to, well, that I can keep on expanding, and this is it. So it's the concept, or the idea is based on a modular mixing panel concept from the 1970s from Philips. So they sold modules that you can build your own mixing table with anything that they could build. So that was an interesting concept. So I have in the cabinet 2 power supplies, plus minus 5, plus minus 12, plus minus 15. And everything is powered from those. So the cabinet is MDF, 80mm, the back as well, because a lot of stuff is mounted on the back. The design of the cabinet as well will be on the GitHub page. And the concept of the modules is like this. This is battery tester I'm working on. Hardware is almost complete, software needs to be done. The board in the back, 2 front panels, and one has all the screws, like the screws for the LCD panel. They're on the back panel. The mounting brackets for the PCB are on the back panel. Everything is held together by the screws or the nuts from the rotary encoders. So that way I don't have a lot of screws in my front panel. So this is the main concept, a few spacers in between, and that's basically it. So the boards are standardized to 101.6 by 101.6 millimeter. So I can take full advantage of the special offer from one of the manufacturers of the boards. Very cheap, less than €5 for 5 boards, so very professional quality. So that's the concept of each of the modules. So they have one connector for the power, so all the powers come in here, and that's basically it. Most of them has ESP32 microprocessor board. I use this one and I keep it standard. So that's the main concept. A quick look at the modules. As you can see, the rack is already full. I have completed a second rack and I'm building a third one as well, because I do all the development of the software and so on in my office, and I need something to power the modules that I'm testing. So the module so far. Let's just power it on. As you can see, they'll show a splash screen and then go to in sleep mode. I didn't want all power switches all over the place, so this is the way I dealt with it. So I can just power it on by pressing the right rotary encoder, and then I get the menu of the functionality. Just power on a few. Functionality will be similar. So there we go. So on the rotary encoder you can turn it for whatever function I designed it for. You can do a short push or a long push. A long push usually gets you to the menu. And the menu I can put the module back to sleep if I'm done with it. So signal tracer, just a basic signal tracer. I can do AF, RF. I can set the attenuation, the volume. Very simple. CB tester, I did a video on that as well, to test microphones for CB. It also can provide signals to test the transmitter part of the CB. ESR meter is based on Bob Parker's design, but I replaced the entire microprocessor section with the ESP32. That's quite a challenge. Capacitor foil checker to find out which lead of the capacitor is connected to the outer foil. VI tracker, similar to a Huntron tracker or a Polar tracker or a VU data tracker, but with a lot of settings for voltages, frequencies, serial resistance, 2 channels as well. Short seeker is basically a milliohm meter to locate shorts on a printed circuit board. It has an indicator here and also a sound. The pitch of the sound depends on how close you get to the short, and you can reset it manually, you can set it automatically. A bit similar to EDS89, but a completely different concept, using very low measuring voltage as well. The RF probe, that's not my design, that's the Ultra probe from Carson's lab. What I did was I designed a small PCB for that, and it fits nicely in this 20mm stainless steel cheap cigar case. So, and I didn't use a speaker because I didn't have the space, so I used the signal tracer as an external amplifier for it. And everything else here as well, the board is similar to the design. The only thing I changed is for one of the switches was a toggle switch, and I wanted to use these switches. So there was a spare 4016 gate. I configured this as an inverter for that function. Apart from that is the basic Ultra probe. DMX tester to test DMX equipment, both transmitting and receiving, so I can simulate a control panel, and I can also simulate a device to test the control panel. Clock timer, sometimes just a clock timer. Very simple. I have a timer and I have a countdown that I can set. Very simple design for that. I didn't even design a board for it. I use these boards. So I made one prototype board, and with the CPU and whatever I need connected to power supply. So I can quickly build prototypes or very small designs, like the clock timer is just an RTC that's in there. So that can be done on a board like this. The TC1 is just a TC1. I took it out of the housing and put it in here because I don't like batteries. That's basically it. A TC1. Ring tester I'm still working on to test flybacks and LOPTs. Frequency counter, basic frequency counter, still work in progress. Bit challenging. It uses an FPGA for the counting part. Yeah, I'm not so good at FPGA, so if someone wants to collaborate in that. Battery tester I'm working on with variable load up to 9 volt, 12 volt batteries, I don't know. still work in progress. A LED tester is in development, that's partially designed as well. So if anybody has a nice idea for some more modules, let me know. So as said, I will publish the designs on my GitHub page, and I'll do some more videos in detail on each of the modules and how they work, a bit about the basic of the circuit as well, similar that I did for the CB tester.